Hey guys, welcome to the Material Science and Engineering virtual tour. My name is Alex Mayfield,
And my name's Katie Sheely.
and today we're going to be talking about the Material Science and Engineering department and why you should pick this as your future major. So to start off, we kind of want to define what material science and engineering is. So material science and engineering basically just works with materials. We use them in every single industry and innovate with these materials. So these are the basic materials that we work with. Those are going to include metals, ceramics, polymers, composites, fibers, and theoretical and computational design. So your polymers are going to be basically your plastics. Your fibers is going to include fiber optic and things such as that. Your metals up there, we have a cam for a car being 3D printed, which is pretty cool. And then on the top right, we've got ceramics, which are being used inside jet engines. So as you can tell, all of these are being used in super advanced industries. And that's one of the cool things about material science engineering. You can actually use it in any industry you want. So next, we're going to talk about the kind of research that we do at Clemson University. A lot of students work with different professors. And down there at the bottom left, you can see a picture of Dr. Urban making this with his hands. And one of the research activities that he actually does is self-healing polymers. So you can see that little thing in the middle. It has the 0 minutes, 10 minutes, 30, and 60 minutes. And that actually is a microscopic image of the polymer that he has created self-healing. So at 0 minutes, you can see that there's a fracture in the middle, but at 60 minutes, the fracture is almost completely healed. And the application that he's actually trying to do with this is making self-healing phone screens. So if you can just imagine that, you can drop your phone and then you leave it on the table and an hour later it is actually healed. And that would just save a lot of money and a lot of time and reduce a lot of waste that's going into the world through phone screens that just can't be reused. So that top left picture is actually a picture of a titanium hip implant, and material scientists are involved in the metal that is used in the implant, as well as the procedure that is used to put it in, used to make the hip implant, as well as the procedure to put it in. And then we've got other things such as Clemson football. I'm sure that if you're applying here or if you already go here, that you've heard about our football team. The material scientists are directly involved in designing helmets to help improve the safety of the game. We've got masks, which are super important in the COVID-19 era. And then we've got other things such as high efficiency lamps for the football stadium, as well as solar cells to help start providing renewable energy for the earth. So you may be asking at this point, how do I earn a degree in MSc at Clemson University? So freshman year, you actually start learning calculus, general chemistry, and you take a lab with general chemistry. You take general physics, you take an English class, engineering skills, which is going to be your basic unit conversion, as well as some basic physics. You've got problem solving, which is going to take the form of a programming class. We're currently learning MATLAB. And with some general education requirements, such as a history class or a language class, you'll wrap up your freshman year. And your freshman year, you're actually going to be a general engineering major. You will not have declared a major yet. But come sophomore year, you'll be asked to declare a major. So you start off sophomore year by taking Intro to Materials Science, which is going to be your basics about unit cells and how materials are made, what kind of materials there are, all sorts of good stuff like that. And then you take Intro to Metals and Ceramics, which is going to be diving deeper into metals and ceramics, how they're made, what kind of crystal structures in a metal or ceramic, and things like that. You're going to take more calculus. People typically take Calc 3 and Calc 4 this year. We'll take Organic Chemistry 1 and 2, plus OChem Labs 1 and 2. You'll take more physics. You'll take statics, which is basically an advanced physics class. And then you're going to take engineering graphics, which is going to take the form of SolidWorks or AutoCAD. That was one of my favorite classes, and it was really cool. So junior year, this is the hard year. You've got characterization of materials and fabrication of materials, both of which are labs. They're going to be with your fellow MSc majors, and they're really cool. They're really small. You're going to have a lot of fun in there. And then you've got Intro to Polymers. This is a lot of people's favorite class in undergrad. The professors are great, and you learn a lot of really good stuff. And then these are going to be the hard classes coming up. You've got thermodynamics and transport. Both of those are basically physics classes, and they're pretty tough, but you'll get through it. Behavior of materials and statistics, economics of processes, which is basically just an engineering-centric econ class. You've got communication skills, which basically is how to give a good speech, and then professional development, which helps you develop those skills that allow you to be a successful in the professional environment, such as resume writing or cover letters, how to apply to jobs, how to carry yourself in the professional environment, things like that. And then senior year, this is something that's really important about our major to know, is that we actually have individual emphasis areas that you can choose and kind of pick your own adventure. And it allows you to get through all the stuff and get a really good base of from freshman to junior year. And then senior year, you can pick what you're interested in and what you want to work on in the future. So our emphasis areas are advanced manufacturing, polymer structure, synthesis, and design, energy materials, photonic, electronic, and magnetic materials, and biomaterials. So all these classes are going to include, or I'm sorry, these aren't necessarily specific classes, but they include classes. So examples of classes that you could take are additive manufacturing, which is basically going to be 3D printing with plastics, metals, or ceramics, which is a really cool class. I'm taking that right now. You've got innovation of sustainable materials. So that's going to be a class that is centered on how to create materials that are useful in the energy sector. So that's going to be your solar power, your wind power, your geothermal power, things like that. Biomaterials, that's a really, really cool kind of blend of bioengineering as well as material science engineering. And that's going to include a lot of stuff like how bone can grow into titanium alloys and things like that. It's just really cool. And then after that, research fundamentals. So that's going to be when you pair, every material science engineer has to take this, and you pair up with a faculty advisor and you work with them to actually produce a semester's worth of publishable research, which is not something a lot of different majors do, but it provides a lot of valuable experience in the research world and helps you kind of figure out, like, do I want to go to grad school? Do I just want to go straight into industry? And that's really illuminating experience for a lot of people. And then you've got senior capstone design, which is going to be a class that is centered around like design of experiments, as well as how to plan a project from start to finish, how to manage your time when you're doing a project like that in the real world, things like that. And then you got to finish off your gen ed requirements. And that's going to take the form of different lit classes and stuff like that.
This slide shows you the advising within the material science and engineering department. We are a generally small major, so each undergraduate student and graduate student gets not only an academic advisor where you're required to meet every semester, you are basically working with them every semester towards whatever degree you're pursuing, in this case, material science and engineering. Class selection, so you're picking that emphasis area for your senior year. Fundamentals of engineering exam, if you choose to take the FE, and towards your PE to become a professional engineer. And then just help you kind of figure out, okay, do I want to join a student club? Should I study abroad? What scholarships are available to me? So that's what your academic advisor does. But because we're so small, you are also able to get a professional advisor. So each student will be assigned one. It's the student's choice to meet with them. If they find that it's beneficial, they're able to go there or go to their advisor once a semester or more, depending on their schedule, and just talk to them about career moves. So internships, co-ops, job placement. Is graduate school something that I want to do? Do I like research or do I hate research and want to go, start working in industry? So we provide a very clear path and try to help our students make sure that they're making the best choice for them. So another benefit of being a small major is that we have lots of scholarships available for material science undergraduates. If you're interested in the courses and you are trying your best, it's not that difficult to achieve. So it's likely that you'll be able to get some student funding or financial aid from the department to help you out with your tuition. And this says 57% of MSE students are eligible. That was for 2019 to 2020. That's a pretty large chunk of students. Who is part of the MSE department? This shows just how small we are. Because we're so small, we only have 2 main buildings on campus that we reside in. This is Serene Hall and Olin Hall, where we are able to have labs in the basement and do our classes in the top stories. And then we also have the Advanced Materials Research Lab. This is about 15 minutes away from campus, but a lot of the students, when they do their required research course, will end up getting to go there. Also through the MSE labs, you'll get to see the SEM and just kind of microscopy machines that they use. And these are really high-end machines. So it's something that students at a lot of other colleges are not able to say that they've experienced working with. So these are some of our co-curricular activities. Every student at Clemson has the opportunity to do study abroad if it's something that interests them. So that's something that you would just talk with your academic advisor. Now you can choose a co-op or an internship. This is something that you would do to get experience to put on your resume before you graduate. This is something you would talk more to your professional advisor about. But basically, you can choose a co-op, which is 3 committed rotations, a summer, fall, and a spring semester, so that when you graduate, you've got a year's worth of industry experience. And that's a little bit of a bigger commitment in comparison to an internship, which is usually just a summer time period, and it's about 10 to 12 weeks. Through the National Science Foundation, REU's research experiences, they are offered during the summer, and they are paid, and you are paid to go live and conduct research at a different university. And then lastly, we have our professional chapters. So we have Material Advantage and Keramos. They are through ASTM, TMS, some of those ceramic heavy organizations. And they basically, all year, you work to create and design a mug or disc to compete with at their annual convention called MS&T. It's a really cool convention. And then Phi Psi is a honors fraternity offered to the material science and engineering students with a high enough GPA. They also have an annual convention in which people will go. You and your chapter, as well as other chapters across the nation, will go and tour plants or wherever they're able to set up each year. And then there's Tau Beta Pi, which is for engineers in general. It's not specific to material science and engineering, but it's also an honors fraternity. What do you do after you graduate? So on the left, this kind of shows where you can choose to go to if you want to graduate with your BS or MS. Everyone needs a material science and engineering worker if they have materials as a part of their product. So the possibilities are endless. But if you decide that you want to get your master's or PhD, you can do that. We have someone that recently graduated that is going to MIT, and we have a senior this year that will be going to Cambridge. And then you can basically take the graduate school route, or you can go into professional schools such as law, medicine, and dental. So these are the expected job placement figures, and these numbers were estimated from Glassdoor. So just a little info, but these are our placement numbers. So right after graduation, 68% of our students go into industry, 16% go to graduate school, and then the last percentage is 16% seeking employment. And that percentage just shows the students that as of graduation, their senior year, they are seeking employment. They haven't been employed yet. So it's likely that within the next 3 to 6 months, they're employed. These are just the people that haven't found one immediately after they graduate. The engineering department at Clemson provides the BS to MS program for material science and engineering. The requirements are to have completed 90 credit hours as a senior, have a 3.4 GPA. When you apply to the master's program as an undergraduate, you are able to then take those tech electives your senior year that Alex was talking about in our courses. Up to 2 of those classes will count towards your master's degree. And that means that you're going to be able to graduate earlier. and spend less money overall. And so the benefits of this would be you don't have to take the GRE. You don't have to pay to take the GRE, and you don't have to apply or pay for the application fee for graduate school, which can get pretty costly for certain schools. And then also your undergraduate scholarships, if you're taking those classes your senior year that count towards your master's, you're still able to apply your undergraduate scholarships to that. So it's just a very cost-effective course. These are our advisors, Ms. Laura Keinert and Dr. Thompson Mefford. If you have any questions, feel free to email either of them. They're very sweet. And if you have any questions where you want to ask either me or Alex, feel free to reach out to them and get our emails from them, and we'd be happy to answer anything. But as for now, thank you for watching, and we hope you enjoyed.
Thank you.